Alright, so this is Precalculus 9.6, example problem number 4 for test. So we're trying to prove by mathematical induction. That's what the statement is true, right here. How do we start? Well, first, before we show piece of one string, we want to write what? Well, not the explicit rule, but we want to make sure we write and say what we're trying to prove. So maybe just erase the number 4 and say prove piece of n, colon, prove and then below the statement we wrote, right, is true. Where is this? For all positive integers Alright, so now step 1. That's outcome. Outer. So, supply. Okay, how's it going to do? Correct. Notice the rule is 4n plus 10. So you're going to show that piece of 1 equals 1 times 1. Then Bryce is going to add some things on here that we want to make sure that we have. This is step 1. Forget about that. We want to save, but this would be piece of 1. And go ahead and simplify that. Yes. Okay, what's step 2? Right first. Boundary. Let's write out the piece of case paper. The whole thing. Okay, so then what? Then what? Step 3. Okay, how do we show a piece of k plus 1 is also true? Not add 4. We need to add the next term. So the next term would be where you need to take your 4n plus 10. Or I'm sorry, not the 4n plus 10. We got to go down to where we got k. The 4k plus 10 and replace that k with the k plus 1 and add that to both sides. So we'll just pause this recording so it doesn't get too long and let Bryce write that stuff up. Okay, so what Bryce has done now is he's showed you what he has to add to both sides of the piece of K statement to get the piece of K plus 1 statement. We have, when I press record, it takes it off the monitor. So what he has there is he's got this piece of K plus 1 statement. Now, we know that if we added 4K plus 14 to both sides, we would get the piece of K plus 1 statement. The question is doing that going to be the same as taking the right side that we started with here and replacing those K's with K plus 1? If adding what we know would get us the next step or the next statement, the piece of K plus 1 statement, if doing the 2K times K plus 6 that I circled in red, if replacing those with a K plus 1 is equal to what Bryce just did on the right side, then that proves that our statement is true. So what you need to do now is you need to compare this right side of our piece of K plus 1 statement with the right side of our piece of K statement after you replace the K's with K plus 1. Questions on that? Alright, let's write that statement out here, Bryce. So what Bryce just did was he told you what you're going to do is you're going to compare the right side of the statement you just wrote, piece of K plus 1, excuse me. We're comparing that to the right side of our piece of K statement with K plus 1s, replacing the K's. And then now what you want to do is you want to take those two statements, simplify them or combine them or do whatever you need to do to them to see if they are actually equal to each other. So Bryce, what is the sub K plus 1 sub K plus 1 statements? There's nothing true. By mathematical induction, piece of n is true by mathematical induction. Yes, I'll let you write that. All right, there's Bryce's final statement. First hour precalculus class.